Okay, in this book, page 40, and this is the problem that we are trying to solve. So stop the video, try to solve it on your own. So in this problem, the mass of the beam is negligible, so we don't need to be worried about the force of the beam, the force of gravity on the beam or anything. So the rope exerts 50 Newton horizontal force, so there's only a tension from this rope, and there is a load, the gravity of this load, the weight of this load. So we are dealing with torques, and here is the pivot. So the torque of this tension must equal the torque applied by this load. I call it torque of the load. So the forces that I am dealing with, of course, one of them is this force, which is actually like this. This is the F of the load. I have the R of the load, and I am looking for F of the load. And what about this one? I have a tension here. I don't have it, but I have some information about it. Let's say this is the tension force that I have here. This force of tension is actually it has two components, and the horizontal part of it is given to us. This is the information I have about it. So if I divide it to its components, this is given to me, which is 50 Newton, and this F of the tension, the perpendicular, is what is causing the torque for me. So what I need is R of the tension force with the force of the tension perpendicular. So the perpendicular part is the one that causing the torque for me. So this is what I have to find. In order to find this, I have this angle. This is adjacent that I have, and I don't have the opposite actually in this rectangle, and this triangle, this is the opposite and is equal to this one. So I know that tan of 30 equals opposite over adjacent, and tan of 30 equals ft perpendicular to 50, which is the horizontal part. So ft perpendicular equals 50 tan of 30. So now I have everything I need. The R is 1.5 times tan of 30 times 50, and 2.1, and F of L. So F of L would be and this is my answer. You can use your calculator to find the final answer.